So in the beginning, we had to look at the way to integrate this fantastic tool in our workflow, in the daily practice, on how the radiologists are working with the acquired images or the acquired data, and how and when they are looking at those images and data. So of course they all work on a PACS, on an image archiving system, and for me it was very important to be able to integrate synthetic MRI in the PACS environment. So fortunately, with respect to the acquisition part, we were able to obtain the sequences on the respective 3 Tesla systems in our division. And on the other hand, synthetic MRI provided us the post-processing tool as a plug-in on the PACS. And this enabled me to convince radiologists to have a look at it, to find out what is interesting, what is new, and what in the future we could do with those new data from the patients we are scanning every day. Indeed, in our institute we work on Siemens 3 Tesla as well as Philips 3 Tesla as well as GE 3 Tesla. So already from the start it's interesting to be able to compare, to use synthetic MRI on the 3 systems, and that is also one of the reasons why it was very important to be able to have the post-processing as a plug-in on the PACS. So acquisition on the acquisition console, of course, and post-processing on the PACS. So today we are able to use synthetic MRI and the 3 vendor, the 3 Tesla systems, and we are able to compare the results on the 3 systems. But also, of course, that's not the only purpose. The real purpose is that we are also now starting up a number of projects, studies, looking at parameters coming out of the post-processing of synthetic MRI, in particular volumetric parameters, for instance applied in young-born children, in neonates, or even in premature-born children. And there we think we are obtaining at this very moment very interesting results. So we started up a collaboration with synthetic MRI, and in the coming months and the coming year we will create quite a big database of young-born children in order to look at, be able to look at the parameters that come out of synthetic MRI in those young brains. The clinical importance of quantitative MRI will be the fact that MRI will become a kind of laboratory tool for the human body, whether it's the brain or the liver or any other organ in your body. You will be able to kind of make a test, a lab test of the patient, and to predict or to observe a number of things, a number of markers and a number of phenomena going on in the body of the patient. So in that respect you could say that MRI imaging today is a kind of qualitative way of looking at the patient, and of course it's the way today to discover pathologies, but in the future there will be a much more precise and reproducible way of doing that through the quantitative MRI approach. And I think synthetic MRI is a very nice, a very solid illustration of the possibility of MRI to detect and to produce quantitative data of the patient, in this case, in our case, in the brain of neonates, for instance. When we talk about parametric maps, most of us think about famous color maps that were already introduced a long time ago, also in MRI. But at that moment, color maps were considered as kind of gadget or aid tool for the radiologist to get a different view on the same image, as a matter of fact. Nowadays, thanks to quantitative MRI and to the production of real precise data, the color map becomes a really important tool for the diagnosis itself. And so the color scale will has its signification, and the color in the image will enable the radiologist or any other person that has to analyze and to diagnose the patient, help them to decide on what is happening in the organ or in the body. Well, the last years it became very obvious that one of the most important strengths of MRI in the future, which means probably the future of MRI, will be quantitative MRI, based on the detection and the quantification of biomarkers. Now, in that respect, a number of developments are going on. Everybody knows about fingerprinting, everybody knows about T1, mapping, spectroscopy, but I think personally I had the impression that synthetic MRI is a real practical and ready to implement way of developing quantitative MRI, and that's exactly what we are doing now. For instance, in the brain of young-born children, we are able to obtain volumetric parameters, and we are able in this way to start up studies and correlations with some other pathological markers or data of the same patients. So that's the work we are doing today, and I find it personally very interesting. Also, the pediatric neuroradiologist is every day working on this topic, and we are looking forward to the results we will obtain in the future in collaboration with synthetic MRI.